Welcome everybody back for another session of PTV Talks focused on Vistro. My name is Bill Sisko. I'm Manager Urban Planning and Traffic Engineering here at PTV Group based in our Portland, Oregon office. I'm excited today to have with us Eugene Mehta with Santa Clara County Valley Transportation Authority. I will transition over to him momentarily and let him do a self-introduction. And also with us today moderating is my colleague Adam Lynch. And we're happy to have Adam. He will be staffing all the Q&A as the session goes on and during the live Q&A session as well. So we're all happy to be here today and thank you for joining us. Just would like to go over a little bit on the agenda, what we're going to cover. Eugene will talk about VTA in terms of the various content and context as a summary, what VTA, who they are, what they do, and how they do traffic analysis and what their needs are, and why and how they use PTV Vistro. And then I will go in and explore a bit within the Vistro software of what their model looks like and how it's been set up. And then Eugene will talk about some future modeling plans at VTA, and we'll go live to Q&A at the end. All right, with that, Eugene, I'll pass it to you.
Thank you, Bill, and good morning, everyone. Good to be here today. Just a little bit about my background. I'm a senior transportation in the congestion management agency side of the VTA. I've been with VTA for about 20 years, but the last 10 or 12 years I've been working in our traffic engineering and toll systems department. And my primary role here at VTA is that I work with all of the traffic or transportation engineers where we collaboratively work on congestion management related issues at the county level. For example, implementing like complete streets, that it's done with some level of consistency. Also, we have applications of our transportation impact analysis guidelines, so that when we review land use development projects that come into the county, that they're analyzed with some consistency, and that's why we chose Bistro. That's how kind of the preface of that. So when Bill reached out to me asking if I'd be interested in participating in the PTV Vistro talk session, I was actually really excited about the opportunities to share how our team is using PTV Vistro to help us with our congestion management efforts here in Santa Clara County. So we can also would like to hear from others to see what other folks are doing. And with the help of a consultant, if I can preface this presentation, we reached out to PTV to see how they could help us with our congestion monitoring needs. And with that, I'll start off describing our agency to provide some context behind our needs here. So VTA is, we're both a transit service provider as well as a congestion management agency. So some of the transit service modes include, as you can see on that slide here, bus, light rail, paratransit. We're also in joint partnership in operating heavy commuter rail service with our peer counties here in the region. A little bit about our light rail system. We have 59 stations on 42 miles of track. We're also part of the Bay Area Rapid Transit system, which has 131 miles of track in the Bay Area, along with 50 stations. And that includes a new 15-mile extension with 2 stations here in Santa Clara County that extend down into San Jose and the city of Milpitas that just opened up in December 2019. So some of the other commuter heavy rail services, we have ACE, Capital Corridor. Those trains come in from like from Sacramento and from Tracy. And those are for the more regional commutes, as well as we also have paratransit, where we have a fleet of about 100 minivans to provide paratransit service here in the county. As far as our bus fleet, we have about 460 buses, nearly 4,000 bus stops, and on 50 routes. So next slide. So on the congestion management side, VTA has a multimodal program to support California's greenhouse gas emissions and vehicle miles traveled reduction goals. That includes we have an express lanes and toll systems program. We have a bicycle and pedestrian expenditure program that includes complete streets and Vision Zero safety program to reduce or eliminate, if you will, fatal and serious injury collisions. We have a local roads and streets and expressways program that actually is geared towards maintaining the local streets and roads that we already have, which is always a challenge, never enough funding. We also have a highway program that seeks to improve and update many of our outdated interchanges that were built in the 50s. And we have a lot of substandard, if you will, on and off ramps and interchanges that need to be updated. We even have a development review program within the county where through a collaborative effort of multi-jurisdictions or developments that come in that generate 100 or more peak hour trips, that we review those developments and provide input in an effort to reduce as many auto trips as possible. For example, asking the developer to contribute towards the bike lane network. If there's a bicycle lane or if there's a gap that's in front of their development, the local cities will ask the developer if they can make contributions to that. Or if it's near one of our what we call CMP intersections, which I'll explain later on in the presentation, they could help with retiming the signals and pay for that. And this is so that the applications, once again, of like complete streets, trip reduction measures are consistent throughout the county. And we also have a transit-oriented development program that's led by our real estate department. And they partner with developers to build housing, whether it be apartments or condos, market or below market housing on VTA excess real estate. So while VTA was expanding and is continuing expanding its light rail system, of course, it requires large staging areas. So we acquire quite a bit of extra parcels, but after the project is done, we try to reuse or repurpose those excess parcels for housing, which is a big issue here in the Bay Area. There's a big shortage of affordable housing. Okay, next slide. So a little bit about Santa Clara County or Silicon Valley. That can be described as a mix of rural, suburban, and urban communities. That has a multimodal network of like toll lanes, expressways, trains, buses, like explained earlier, to support it. We have about 1.9 million residents and regional commuters. And we're kind of in a transitional, if you will, from a suburban to urban land use environment with low to mid-range densities and high auto mode share. Just being in working in one of the most affluent communities in the Bay Area, if not, in the nation, it's very auto-centric here. People love their cars, especially those Teslas. So trying to encourage mode shift has always been a challenge. And even more so after this pandemic, what are the paradigm that we were following pre-pandemic is definitely changed, and now we're just going to have to wait and see what the new paradigm in terms of travel behavior will be. But I would like to use Vistro to help model several different scenarios so that we can right-size our resources in terms of managing congestion. So the major trip generators are high-tech employers. They still want to have a presence despite the ability with telecommuting. They still like to have a presence here in Silicon Valley. We have an international airport. We have large retail shopping centers, amusement parks, sports stadiums, etc. Next slide. So this slide's a little bit outdated. It's about 10 years old. I need to update this, but I just wanted to show and give some perspective of some of the major trip generators here in Santa Clara County. So what you're seeing up there is almost kind of like it's oblong. We call it the golden triangle, where most of our high-tech companies are concentrated. So we do have a strong employment base, but the economy does come with some unintended consequences, right? And that's traffic congestion. So we do our best to mitigate for congestion through better planning and coordinating both land use and transportation into our communities, which is the purpose or premise for our Bistro project. Okay, next slide. So here's a need for a traffic analysis software tool. One I'll point to is that it's legislation under California. So here's a reason for I need to have an approved traffic analysis software, which is granted unique to California. We have a statute that requires congestion management agencies like VTA as a recipient of gas tax funds. So there's a small percentage of the gas tax that's redistributed to congestion management agencies or counties throughout California. But in order to receive that funding directly from the state requires that the counties establish a congestion management agency. And as part of that, we are required to monitor our roadways, our designated, we call them congestion management roadways. And we're required under law to conduct the level service analysis of the CMP roadways every 2 years. So this is to ensure that the county and the cities and towns are developing programs to maintain a traffic level LOS standard of E. So in 1990, the California legislature enacted the Congestion Management Program to implement Proposition 111, which is that gas tax. And I do highlight in the second bullet that we needed some way of uniformly analyzing traffic with some consistency, and that's the reason why we only use one software. So, and the reason for that is that there needs to be some transparency and reliability on the data output, because if a CMP intersection falls below level service E in any of the cities, that city is now on the hook to develop what we call multimodal improvement plan. It used to be called a deficiency plan, on how to mitigate the level of service from F back to E, and whether it be encouraging mode shift from from single occupant vehicles into other modes, like into transit. So that's the key reasons for having the need for a traffic analysis software. Okay, next slide. So how we are using Bistro at VTA. So I mentioned earlier that we use it to measure traffic and transportation impacts from land use developments. We also use Bistro to identify potential air quality or trip reduction mitigation measures. For example, like we'd like to know what happens if you add a bicycle lane and we add some trips to that. Will that encourage a mode shift? or reduction of trips that will contribute towards improving air quality. And everything's towards air quality, right? It's geared towards improving air quality and reducing vehicles miles traveled. And also, we use Vistro to monitor our CCP intersection network. And once again, I like to highlight consistency. So if any members from the public or city councils ask, inquire about what methodology that we use, we can all point to one software. So we can all say that this was approved by our VTA board and your city, their cities as well. So, and that's to also reduce the opportunities, or we might say risks of litigation. Okay, next slide. So here's a map of our 252 CCP intersection network. And these intersections were identified in the late 1990s. That's monitored every other year. Essentially, these intersections act as congestion monitoring stations, if you will, kind of like the air quality monitoring stations. And as a performance indicator for measuring how well we are integrating land use and transportation to manage traffic and achieving statewide air quality and vehicle miles traveled goals over time. Okay, next slide. So here's a partial list of our congestion management guidance documents. The highlighted guidelines specifically identifies the traffic analysis software that must be used for analyzing transportation impacts, primarily for land use development projects here in Santa Clara County. Because what we find is if we receive developments to review, and we understand there's several different softwares out in the market, it's difficult to analyze the developments with any kind of consistency, right? Whether you use one software or another software, if there's two different softwares out there, you're going to ultimately end up with two different data outputs. So once again, for consistency purposes, we just wanted to identify one software. And also in California, holding the title of probably the most litigious state in the nation, using a consistent methodology can also help minimize the scrutiny of the methodologies that our consultants and traffic engineers use as part of our transportation impact analysis guidelines. And this becomes a point of contention, especially when developments like, I can tell you, like Trader Joe's, if you guys are familiar with that, or fast food chains like In-N-Out Burgers are built like near jurisdictional borders that may cause congestion, in nearby residential communities and adjacent jurisdictions. Those types of developments typically become high profile within the local communities. So using one software helps in terms of reducing questions or inquiries about the methodology that we use. So next slide. So why Vistro? As part of our transportation impact analysis guidelines, we ask that the developers analyze existing conditions, then existing plus project conditions. And also there's another scenario that we have to analyze is the existing conditions plus all of the approved trips, and then lay the project conditions on top of that. And then we also have a cumulative set scenario that analyzes, what traffic would be like in the future using kind of a set, which call it increase, or if you were like a 3% annual increase in terms of number of trips. So the communities can understand what traffic may be like in the future. Also, we needed a software that was compatible with current methodologies. For example, we're still using HCM 2000. Probably want to use the latest edition. I think it's HCM 6. You also need the flexibility to add customized software features upon our users' request. And PTV has been very, very receptive and always wanted to know what their customer service needs are. So, for example, we like to have the ability to set default saturation flow rates. Or I think we're still using HCM 2000, where for through lanes, we like to have a set saturation flow rate of 1900 vehicles per lane per hour. And on the through and right and left turn lanes, it's 1800 vehicles per hour. So there's some consistency once again, right, when you're analyzing the development and especially the transportation impacts. And also PTV recently added the right turn on red percentage function, at least here, which is applicable here in California. I understand that in other states, like red literally means stop. You'll just have to wait for the signal to go through its cycle before making that right turn. But folks here in California, we're in such a big hurry that nobody likes to stop for anything. So, but we want to be able to measure with the realistic conditions of traffic on the roadways. So also there's a versatile use of Vistro because it comes, there's a suite of other softwares that tie into Vistro. So when you're moving data from one platform to another, if you stay within PTV products, that is very seamless. So you can move the data from Vistro into Visum into Visum. And also the convenience of the software license, right? There are other softwares out there where the software license is literally tied to the individual. And if that staff leaves, it's really difficult, right? It's not convenient to have an individual license versus a seat license because staff's always changing. All right, next slide. And with that, I think I'll pause here, and I think Bill will provide a few live demos.
Yeah, thank you, Eugene. The excellent presentation. We'll come back to Eugene in a little bit. He has a little bit more to share with us towards later on in this webinar. All right, so what I'm going to do now is transition in to show you guys what VTA's Vistro model looks like. What I thought I would do is do a little compare and contrast. So bear with me as I get out of PowerPoint and transition over. So similar to the answers from that first poll, what you may see many times in your analysis or your projects are maybe corridor specific models. Like we have this one here that's in Ontario, Canada, corridor along a major arterial with about six signals in there, and this is pretty typical for various types of studies. You may then graduate up to something a little larger. Maybe it has a longer corridor and maybe a perpendicular corridor, such as this one in Montreal, Quebec. And then looking at just we're growing here. We're taking baby steps. So get a little bigger. Maybe you do some of the downtown network. Maybe that's in that 6 to 11 network size or something like that. And then otherwise you may be doing something that's a little bit more suburban, various road types. One of my presenters, if you guys can mute, we're hearing stuff from you guys. If you're not talking right now, please, thank you. And then basically all that, drum roll please, to get up to the point of looking at something in a larger area, modeling in Vistro, such as the topic today. Let's take a look at VTA's network. And so this is VTA's network. For those of you familiar with Vistro, of course, we have our Bing imagery, satellite imagery. That's a active feed here. I used to use the word live until all the live traffic data became so prevalent in our industry. But it's live in terms of the fact when I pan around, of course, that the background map goes with me because it's a satellite image. But here is a quick overview of the 252 signal intersection VTA's CMP network. And as Eugene described, this is basically in the San Jose, California area. Santa Clara County is one of the 9 Bay Area counties on the south end of that metro area. A couple of things I'll point out here, just so we can kind of look at sizing in statistics. In this case, 252 signalized intersections that they monitor. We have a couple extras in here, and a total of about 1,300 intersections in this Vistro network altogether, including some two-way stops and a bunch of unknown or dummy intersections to in the network building process to provide various access points and curvature and so forth. But you can see how large this is. Definitely the largest Vistro network that I'm aware of, and it does just show the flexibility of Vistro from not only a corridor specific or project specific software, but to be able to really model an entire region, if you will. I mean, it's not the whole Bay Area here, but it is a quite a large county, as Eugene mentioned, almost 2 million people, and quite a number of roadways and intersections. I just wanted to poke through a couple things for you guys. I know you've seen a lot of things about Vistro, but when you have something this large, some things that of course will come into play or remind you of ways that you can manage kind of the views, and really in something like this might be a good chance to temporarily at least turn off the satellite imagery and get a better look at your actual network. I think this highlights it a lot cleaner in this mass scale view. And of course, we can still go in and do El Camino Real or some major corridor like that and look at Vistro specifically in sub areas of the Santa Clara VTA region. As we've talked through some of our previous getting to know Vistros, there's also, of course, the ability to kind of mute some of the stuff on the satellite imagery and then post things. One of the benefits of such a large network that, as Eugene was mentioning, in terms of especially the consistency aspect, or the aspect that there's a model from which not only VTA can use Vistro for multiple purposes, right? One is the CMP monitoring that they're required by law to do every 2 years, where they're keeping track of existing conditions on a year-on-year, in this case, every 2 year is a requirement basis, but also as a basis, as Eugene also mentioned through the slide that listed their guidelines, that this Vistro network will be the basis for any of the impact analysis studies that are being done within that jurisdiction that hit the certain minimum trip generation threshold. And therefore, you're always starting from a common starting point, right? And so, as Eugene had mentioned, the VTA in Santa Clara County covers 15 member agencies that are either labeled as a city or a town, and then as well as one county, the Santa Clara County roads that deal with the unincorporated areas of the county, and also some of the major roadways are county roadways. And so it really provides for that consistency on a county-wide basis. Of course, if I'm all the way zoomed out like we were originally, won't be able to see everything that I might want to post, but you can do a lot of things within the specifics at these larger scales where you can still see some monitoring on quick views, right? So of course, if I'm doing a particular study, I'm going to be zoomed in on where that study is located, but it does allow me a quick look at my network in such a large area and to be able to see how intersections are performing, as we've done through other webinars in our intro to Vistro basics section, I would say, at least. The other thing I wanted to highlight really was, as Eugene was talking about some of the specifics that you can do in Vistro in terms of agency, maybe agencies have certain settings. VTA is well known for this, which is not just applying highway capacity manual as it's printed, but to actually go ahead and make some adjustments based on field conditions and based on the ways that things operate in Santa Clara County. We did work with them. We're happy to work with our customers, of course. What we incorporated in Vistro were a whole set of various saturation flow rates These are VTA standards, but we can edit these. They're available to any of our customers to use. For those of you that need a little refresh on the HCM methods, one of the core portions of the signalized method has to do with determining ultimately what your final saturation flow rates are for each of your lane groups or movement groups, and basically that is typically done by using a default saturation flow rate and then using a series of adjustment factors, lane widths, heavy vehicles, et cetera, maybe starting with the default of 1900, which is the HCM default. But in Santa Clara County, one of the things that they've done is they've based on a whole host of field condition studies, they've normalized what their final saturation flow rates are for various lane configurations. Eugene had alluded to this in his presentation, but the difference between a final saturation flow rate for a single left turn at 1750 versus double left at 3150, which you can tell is less than just 2 times 1750. And guess what? Yes, triple left turns. They're not 1750 times 3. They're much less than that, as you have the interference of lane on lane, side by side friction. So there's a lot of things you can do within Vistro that's highly editable for your field conditions. I won't get into all the intersection specific stuff. We've done that in previous webinars, but I did want to highlight at least at a global level. So if you are an agency that wants to set up some global standards like VTA did, that we have ways for you to do that in this global settings field and really make your Vistro model your own in terms of it, truly reflecting your field conditions if you are able to go out and do these types of detailed sat flow studies in order to replicate that. So I wanted to highlight those aspects of Vistro, and really the other thing I wanted to highlight, if we go back and look at the full screen again, just so we can see the sizing. Let me just put this on roadmap and we can see it a little bit better. One of the other things is about the scenarios, and so I know we've done sessions and we've explored the scenario manager. We've explored how to use that for corridor studies, timing studies, impact analysis studies, all of those things. What I did want to highlight today is looking at this VTA network, and as Eugene had mentioned, we had helped them set up their existing network. It doesn't always go that way. Plenty of our customers do their own initial setups, but in this case, we had helped them do that as well. And then they are adding on multiple scenarios that will affect the impact analysis requirements. So for their CMP modeling, of course, they may just be looking year-on-year existing conditions, AM and PM peak at all their intersections. But as highlighted in Eugene's slide, for the impact analysis guidelines, they have a number of other alternatives that need to be examined, including background, which is existing conditions plus any approved trips in the area, or project conditions, which also layers on your project trips, as well as future year cumulatives that include some future year growth factoring and estimations. And so just in case you're new to Vistro or haven't seen this before, you can have all 8 of these scenarios in this single file and toggle between them. And as you make updates to the base scenario, if there were any tweaks that needed to be done that weren't coded correctly originally, they'll ripple through into these future scenarios. And you can also change things within each of these individual scenarios. So if you have some specific roadway extensions or gap closures or things like that coming on board under a future scenario, maybe it's not an impact land use development project, but maybe it's a roadway project, and you need to study the effect of a new roadway connection, those can be handled on a scenario specific basis as well. So with that, I just wanted to give you guys a little tour live, and you can see the complexity of the network, and you can see how large it is, compared to, let's say, maybe a more typical small corridor. And there's a lot of benefits of having your whole agency's network in one file, not only for your own monitoring purposes such as VTA, but also to have a consistent platform. And I'll just note, I back years ago when I was in consulting, while we would say in any software platform that you implement a method like HCM, everybody knows you're going to get slightly different results, and there's just no way around that, and that's fine, right? We're not talking orders of magnitude differences, just slight differences. But from VTA's perspective and the way that they lay out this monitoring, and I'll let Eugene add to this or let you know I've spoken too much, but I remember that when you have an individual CMP intersection that is teetering on the brink of crossing into significant impact threshold, staying in the same software is key, because even small differentials can cause significant levels of impact in terms of triggering what it triggers in terms of the necessity to do, to look at the mitigating those particular circumstances. And it's not about that people don't want to provide a more efficient intersection necessarily. It's about the fact that making sure that you're doing that based on the reality of the differences of the operations in terms of new trips or signal timing changes and so forth, and not being triggered into that just because of a difference in using one software versus another. With that, I'm going to go ahead and hand it back over to Eugene.
All right. That was good information there, Bill, and providing to the folks out there. And also, I think, Adam, you made a good point. I think in your poll, you said that we would be able to analyze developments with efficiency. And from a reviewer standpoint, the public agency that reviews many developments that come through the county, having to learn and understand more than one software and also be able to train new staff that's coming in. And about this time, we're starting to, I don't know about other folks, we're starting to see like the next generation of engineers and planners come in, because as many of us some of us are kind of close to retirement, like myself. So trying to train, new staff on multiple softwares, that's really difficult. So just having one software does increase the efficiency. Just now, all we need to know is how to work one software well. And also, to Bill's point about the analysis of the CMP intersections, we understand if you use multiple different softwares, one software may show, and it just be through just a minute difference in terms of reaching that threshold on whether or not that city needs to do a multimodal improvement plan, which is a lot of time and effort. So we understand, just trying to keep everyone honest, if you will, that using a single software reduces any kind of inconsistency. So that would keep, once again, the entire process, the development review process, transparent. Okay, so this is a future project that I have, and this is like the ultimate vision for Bistro. Bistro is just the first step, and the second step would be to move the Vistro model into Zoom, so we could do some countywide analysis. So right now, VTA and our local cities lack a software tool to analyze and optimize like traffic mobility for all modes at the county level. For example, when we decide to increase transit service from, let's say, 20 minutes to 15-minute frequency, there's no tool to analyze what that will do, how that will impact cross traffic, especially to vehicles, and more specifically along our expressways. We have like these expressways that run east-west and north-south throughout the county, just because the geography of Santa Clara County is so vast that expressways were created to help move vehicle traffic. But those expressways at one intersection will move or process, if you will, 20,000 vehicles per hour during the peak period. That's a lot of vehicles. And all of a sudden, you stop that flow of traffic, from once every 20 minutes, once every 20 minutes to, let's say, you move to a 10-minute headway frequency to to twice that, that does have some impact, and we don't have any way of analyzing that. And also, with the big push on Vision Zero through reducing, fatal collisions and reducing serious fatalities on the roadways, many cities now, there's a big push to implement leading pedestrian intervals, right? So to give the pedestrians a head start in the crosswalk while it's all red for the vehicles. And we have no way of modeling that. So our goal here is to maximize the flow of traffic for all modes throughout the county. So whether it's bicyclists, transit, pedestrians, and also to be able to present several different scenarios to our elected officials, the board of directors, so they can make a decision, right? So we don't have any one agency, VTA, which is also a transit agency, competing against the county, which operates the expressways along as well as with the local cities. They're responsible for their roadways as well, traffic in their areas. So that way, like I said, we can present several different scenarios and let the decision makers make that decision. And that takes the liability out of the traffic engineers. So, and also this supports a balanced approach for developing congestion management strategies, as I mentioned earlier. And it also follows regional uses by our local metropolitan organization, which is MTC, and Caltrans, which is our state DOT, as well as for the consultant. So that's our future goal there. And the anticipated benefits from this effort, from what I hear from ITE, you can optimize traffic progression ability for all modes between, like they say, 8 to 12%. But I understand it's never been done on this scale. But it'd be interesting to see if we place all of the intersections. And so right now there's 252 intersections. My goal is to input all those 2,000 signalized intersections in the county. And what would happen if you push that optimization button? That'd be just interesting to see. It would take time. I'm sure it would take some time to run that model, but just to see, and that would serve as just a baseline timing plan, if you will, that we can use. And of course, that's going to be modified, but we have some start with some, using, an analysis tool that we can, we've all agreed to use. This also complements our congestion management program efforts of monitoring, managing, and implementing projects. And like I said, been emphasizing throughout this presentation, it provides consistency and transparency in sharing data and reducing redundant work and cost to agencies on a project level basis. So maybe Adam can speak to this. My understanding is that the latest feature of Bistro and Vistro is the ability to stitch together sub-area models. Like, for example, while VK would maintain the county-wide model, the cities could maintain their sub-area models. And what we might, my thought there is that we could let them update their sub-area models, and then we could stitch that into the county model, and it would that would be efficient in terms of trying to keep the county-wide model up to date.
Yeah, there are some workflows that we've more or less published on this urban mobility system knowledge base article that we have, and I can send out the link to that later if you need it. But you're able to work within your Vistro network, and as long as the core geometry is similar, like you have the same node structure and the same traffic signal IDs as you do on the VSUM side, it would be possible to kind of do this like network comparison in vSoom to kind of see what the changes are as you're going from Vistro to vSoom. So that's one possibility, to be able to import these changes in the data and promote it up at the vSoom level. The other thing is within Vistro, we just recently published a knowledge base article, I guess it was yesterday, about using the merge and update tool within Vistro. And that way, if you can kind of split up the work between teams from one model to the next and update a master Vistro network that way. Again, it's kind of under the similar architecture where you need to have like these intersection IDs, like similar between networks, so it knows like what to update and how to update it. But that's usually handled on the agency side because a lot of them have their numbering schemes already. So it's just pay attention to the details like this.